Hi everyone! Today's video is going to explain HR diagrams and how to read them, how to use them, and why they're important when we're talking about stars. After you watch this video, there will be a Kami assignment for you to complete to practice using HR diagrams. So to begin, let's talk about the essential questions. What do we want to get out of this PowerPoint and the lessons and the worksheet you're going to be working on? So we want to know, what is the HR diagram and how is it used to classify the stars? So let's first talk about some vocabulary of the HR diagram. This is an example here on the slide, and what we're comparing is the temperature and the luminosity, and this is how we identify the stars. So the Hertzsprung-Russell diagram, or the HR diagram, is what this is called. It's what it stands for, and it's a plot of each star in the graph that measures the star's brightness or its luminosity against its temperature. Luminosity is on the y-axis and temperature is on the x-axis. So let's dive into this a little bit farther, what these variables mean. So the temperature is measured in Kelvin. Kelvin is its own unit. It is not a Celsius unit. It is not a Fahrenheit unit, but it's a Kelvin. And the color of the stars depend on their temperatures. If you remember from the PowerPoint yesterday, stars that are blue or white in color are much hotter than stars that are red or orange in color. And this color tells us a lot about the surface temperature of the stars. As you can see, the much higher Kelvin temperatures are over on this blue-white range, and the much lower Kelvin temperatures are this red, orange, yellow side of the diagram. The coolest stars are red, and the hottest stars are blue. Now let's talk about temperature some more. As temperature increases from right to left, which is different than every graph you've probably ever seen. Normally, temperature gets, your variables get much larger this direction you go, but on this graph, the coolest is over here on the right side and the hottest is over on the left side. Now let's talk about luminosity. Luminosity is also known as the brightness. It's the amount of energy or light that a star emits. It's brightness. And you can see here there's many different types of luminosities and amounts of luminosity in this image to the right. Brightness is identified or classified using the term apparent magnitude. Yesterday we talked about apparent magnitude, and this is what tells us how bright an object appears from the Earth. The absolute magnitude of a star, though, is the measure of the star's brightness as if it were at a standard distance of exactly 10 parsecs, or 32.6 light years from the observer. So now, let's talk about a spectral class. Spectral classes are classified, this is how we classify stars, by their spectra, and which are the elements that they absorb and their temperature. Remember, we talked about spectrographs in class yesterday. Spectrographs are the instruments that we use to measure the wavelengths of the elements that we see, or that the device sees, and then it produces a spectrum of the different wavelengths that those gases give off. There are 7 main spectral types: O, B, A, F, G, K, and M, and they're listed in order from decreasing temperature. You can see the spectral classes here on the bottom of the diagram. So O is a much higher temperature spectral class, whereas M is a much lower temperature spectral class. The main sequence. So this is where we talked about that stars spend 90% of their time here, and most stars are categorized here in the main sequence. It is this big straight line cluster of points that is in the middle of the graph. About 90% of the stars in the universe, including the sun, are located here. They range from high to low luminosity and high to low temperature. As the temperature increases, the luminosity also increases for stars in the main sequence. They range in colors from red to blue, and they are in spectral classes N through O. The sun is right there where that arrow is pointing. It is a medium-sized star, and it has medium brightness and temperature. You can see it's right in the middle of the cluster of those points. It has a yellow color, which we know, and it is in spectral class G. The red giants, which you can see right here, and the arrow points to it, is a red giant, is a dying star. We talked about this a little bit when we discussed life cycles of stars yesterday. Our own sun will turn into a red giant star, and it'll expand and engulf the inner planets when it reaches its dying stage. Its colors are reddish orange hue, and it has high luminosity but very low temperatures. And it is in spectral classes K through M. Then we have the supergiants. You can see those up here in this top corner, and both top corners, so the blue giants and the red supergiants. They are the largest stars in the universe in terms of volume, although they are not the most massive stars. Their colors are reddish orange or blue. They have high luminosity but low to high temperatures. And they are in spectral classes K through M and B through A. The white dwarfs, you can see them in the bottom corner here. They are a small, very dense star that is typically the size of a planet. They're formed when a low-mass star has exhausted all of its fuel. Remember, when stars start to exhaust their fuel, they start to die. A white dwarf was one of the end stages of stars. They're typically white in color, so they have a very low luminosity but a high temperature. And they are in spectral classes B, O, and A. Then we have the red dwarfs. They are located at that very bottom part of the main sequence. They are small and relatively cool type of star. They're red, and they have low luminosities and low temperatures. And they're in spectral class M. Now, let's check for some understanding. Can you interpret this HR diagram? If you can interpret this diagram, you should be able to tell that as the temperature increases from right to left, and the luminosity will increase from bottom to top. The luminosity is on the y-axis and the temperature is on the x-axis. The stars are plotted on this diagram to help determine color and apparent magnitude, or an absolute magnitude. And different types of stars fall in different places, but most stars spend their time in the main sequence. You can use this diagram to explain how the stars are classified based on their luminosity and their temperature. Now that you've watched this video, please complete the CAMI assignment. Email me if you have any questions.